Introduce actually a Dallas person, Jeb Stone. He is the chief data scientist at Fair Compare, and he's worked for Match.com previously, so he's kind of on the cutting edge of some of the social media analytics. And then I was very fortunate. You'll notice that the names have changed. Also in the social world, the master's degree students decided that they could not show up at the last minute. So I found these two highly talented people because I was being a social butterfly earlier. And they're with Teneo, which is a company out of San Francisco that does New York, that does, well, San Francisco, New York, it's the same. Not really. They're with a management company that does financial consulting. So we have Talal Mufti, who's the VP of Strategy, and Faiz Ul-Haq, who's the Vice President of Data Products. And they've used very large-scale social media data sets to do network analysis and brand strategy. So I thought it would be very interesting to have them today on this panel. And then we're also very lucky, and you guys, some of you are probably planning on attending his session next, which is going to be over in 114, 116. But I also wanted to grab Sai. He's a member of our Dallas Big Data community and involved with Python. And he's just recently gone off on his own and founded Edico Research. So what we'd like to do with this panel is I'm going to hand the microphone first to Jeb, and he's going to kind of share his knowledge and thought leadership. And after everybody does that, we'll allow for a lot of audience interaction and for you guys to ask some questions. Plus, we only have one microphone.
Great, thank you. Is this okay? Hey, everybody, I'm Jeb. Actually, it's Dr. James Carl Stone IV. It is way harder to get people to call you that than you would think. So I'm not going to ask you to raise your hands or anything. You can smile and nod. But, you know, how many people have worked for months or years on something, and they look up one day and they think, oh, my God, what am I spending my life doing? So that happened to me. I was finishing my master's thesis, alluringly titled Instrumental Conditioning of a Leg Lift in the Honeybee, which was every bit as exciting as you could think, as you can imagine. And I realized I was in for a long and lonely life in the lab. And so I switched gears a little bit, finished my degree, got a really cool job where I got to found the analytics team at Match.com. Those guys have some of the coolest, best social data that you'll find, user interactions, chats, all sorts of user-level data. Did a stint in web analytics and helped kickstart a few startups with their first rounds of predictive models that leveraged social data to make money and to help users. And we'll talk a little bit about some of those. Right now, I'm with a company called Fair Compare here in Dallas. We're like Kayak, except way more awesome. So.
Good afternoon, everyone. Like Jeb said, I also did master's thesis, but I did in machine learning. At the time, when what the professors and teachers taught you, they thought, okay, it's exciting and stuff like that. But when you got a job, it is not that exciting because nobody wants to talk about machine learning. I'm talking about a couple of decades ago. But in the last 5 years, things have changed. It couldn't be more exciting for me. AI and machine learning are commonplace terms. I see them on CNN.com and what have you. So that has been my background. And so I worked in the middle a lot on data warehousing and business intelligence and big data space and so forth. But what is interesting for me in this conference is I have spoken a few Gartner BI summits. The level of conversation and discussion, whatever, when I compare that to what I see here, I feel at home. A lot of nitty-gritty about today, somebody talking about assembly code and what have you. It's very exciting. And so I'm so glad to be here and hope I'll be able to answer some of your questions around social media and so forth.
Hi, everyone. My name is Talal Mufti. So I'm a data scientist at a New York-based management consulting firm called Teneo. I started off actually as an industrial engineer and then realized less interested in that, kind of like this thing called operations research, kind of probability, things like that. went and did a master's in that, and then discovered, oh, I really need to build models that are not just statistical, but that actually can feed in and pull in data. And so I'm like, I should teach myself Python. This looks pretty popular. And all of a sudden now I'm a data scientist at a consulting company, having started off more as, more brick and mortar engineer. It's exciting. So some of the work we'll be talking about is in using available social media data, crowdsourcing, marrying that to traditional survey research and how to do sentiment analysis and things like that, how to use that to drive brand strategy. And I'll hand it over to my colleague who also does some interesting stuff with that.
Hi guys, my name is Faiz Ohak. I'm also at Teneo, a colleague of Talal's. My technical or official title there is VP of Data Products, but I've done everything from, putting together spreadsheets to coding to mocking things up in PowerPoint. Who, by the way, does mock-ups on PowerPoint? Just one person? I thought there'd be more. It's there's somebody giving me a thumbs down there. I worked at Microsoft as well before this, and I'll let you into a secret. They also do their mock-ups on PowerPoint. So that's hence the ribbon and Clippy and everything else you love. In addition to what Talal just said, we also use social media data to construct large networks. And what we do with that is your traditional, centrality analysis to find out who is the influencer or who's influencing the conversation or conversations within specific communities. And the fascinating thing that I found when I first started doing this thing about a year ago was that for even very large conversations, say 3 to 4 million social media posts, in the end, it's really about 150 to 200 people who are driving most of the conversation. And that's mind-boggling. It's, that level of influence, it's very kind of top-heavy. And that obviously, leads to very interesting things when you're advising companies on things like corporate strategy, brand strategy, and things which have usually been informed by your traditional survey research. You're trying to do similar things with social media data. So it's a space that's probably different to what most people here are familiar with. So we thought we could talk more about that and how we use traditional data science techniques to inform practices in an industry which has traditionally been very sort of sticks and stones, for the lack of a better term.
So I guess if you take our title here, social media analytics, Python, and you kind of cut that in half, maybe we can start with Python. And I don't know about you guys, but I didn't start out with Python. I started out with SAS way back when. Still use it. It's a great tool. But so the question is, and we'll get into some of the nitty-gritty, I guess, with what our social media analytics are. But why Python? What does it bring to the table that you're using that is either valuable or quicker, or what's the value proposition for that?
So that's a very good question. From my perspective, I do believe and experience in multi-strategy learning, because if you look at it, how we as humans learn, we have multiple sensory organization, multiple things that we look at. So if I apply a particular machine learning algorithm, let's say a decision tree versus clustering versus neural nets, I'm going to get different things identified from that information. So that led me to do more on the NLP side. I was using Stanford Natural Language Processing libraries a lot, but to the point that I believe in the multi-strategy learning and parameter influence and so forth, I stumbled upon NLTK, Natural Language Toolkit, and that is why I started to learn Python. So as you, I wasn't starting with Python, but I've heard a lot about it. I heard someone mention that it is for administrators and stuff like that. But when I saw Python NLTK, my mind opened up and I found a vast area of things that you can do. So in the talk that I'm going to talk about after this conversation, I'm going to compare some of the results that NLTK provided and what the Stanford NLP provided and the differences. But what I like about NLTK is you could extend, configure to how you want to classify text, right? For example, you have a particular pattern of concepts that you're searching in your vast array of textual information. You could create a chunker based on that, and you can have your Python power to go find those kind of information. That kind of flexibility, when I learned and made sense, and that's one of the reasons why a conference like this makes sense for me, because now I have machine learning algorithm implementations in Python that I could leverage. I don't have to go from one representation of information from one language to the other. Right? That's my exciting part of that.
So for me, I guess the interesting thing that I can admit now that I actually have a job, and I think hopefully my resume doesn't look too bad, is that I started off wanting to be a computer scientist and didn't do well enough in the Weeder class of computer science. So I had done the AP, which is basically a high school advanced placement test for computer science, and I thought I was hot shit, but I never actually programmed anything on a computer. It was all on paper. And I'm like, okay, I'm going to skip the intro class and go straight to Java 2. And I mean, I didn't fail, but I didn't do very well. And that really influenced me a lot, because in the beginning, I'm like, oh man, I'm just not that good at it. I tried again, I retook the class, did a little better, took an algorithms class, and that really set up the basis for me as a maybe not a computer scientist, but someone who uses programming. What got me back into it was computational programming. So I started off with MATLAB, just because schools use it, and then did R, because I did some stats classes where they preferred open source stuff, and then kind of left it for a while, had to, so for my master's, even though it's in operations research, my funding was from the transportation program. So I built a basically highly disaggregate transportation model that simulated every trip down to like a census block in all of New Jersey. It's not, I could talk more about that, but in any case, I was like, okay, I need to now go back. I need to do some real programming, not just computational stuff. Am I going to do this in R? Am I going to do this in Java? And some people are like, oh, have you looked at Python? And it was so easy to pick up. And I've just been, using it ever since, really, for everything. Just the versatility of it alone. Not a real computer scientist, other people can speak to how good Python is in those regards better than I can, but that's how I got hooked.
So I think my gateway drug to Python was Django. Back in school, when I was prototyping some apps up, that was my framework of choice. But then I think it's just, and this is what everybody else has been saying, and I echo it. It's just the vast diversity of things that you can do in Python, or libraries that are available in Python and are well supported with great communities. It's amazing. I think very few other languages today could boast that. So you've got at Teneo, for example, we have our web apps being served by Django. We do some natural NLP stuff with NLTK. We run our network analytics with Dato. Shout out to these guys, are awesome. Love them. And we also use SciPy and Pandas to do more kind of SVM-based learning models as well. So it's that diversity, I think, that keeps us hooked to it. That said, though, I think there are things that don't work well with Python too. So one thing, for example, that I found was constructing networks with large data sets. So again, using social media data, if you have a data set of 3 million posts, constructing it in network X is extremely inefficient. I'd love to hear from anybody who knows a way to do it more efficiently. But in the end, we ended up having to work with the Tinkerpop stack and work directly in Gremlin and write in Groovy, which allows the same networks to be constructed 10 to 20 times faster. So there are things that it's not so great for. So I'd ask that question to the panel as well. Are there things that you've found that Python limits you from doing, and what was your work around that?
Well, I'll kind of start with the good and go to the bad here. I guess I came to Python from a little different direction than some of you guys. The environment has changed. The data environment, the analysis environments have changed a lot in the past few years. And it used to be the case that if you were going to get data, you knew what was in it, you knew it was pretty clean, and they just kind of gave it to you. Those were the days. And now, so now we've got all this data on all these APIs, and this, unstructured data, which sometimes it means unstructured, sometimes it means, well, nobody looked at it, we just dumped it on the cluster. And so Python, for me, has really opened up the door to being able, letting me get at that data, letting me fix it, clean it up, restructure it into a modelable program, and I've really appreciated that about it. As far as things it doesn't do well, the SAS program is, 60 years old or something at this point. And so it does some things in a few lines of code that still Python looks more like Java to do a proc freak or something like that. It's just a lot more code to do that kind of thing. But at the same time, though, I'll say, yesterday I was working on loading a 250 million record data set into SQLite so I could run some queries on it because I couldn't get MySQL to return a query on 250 million records, which is not that big. But so I can load that into SQLite in a couple of minutes, run some queries on it, dump the data set, and I've got what I need. So it's really been a fantastic, when you need it, it's a neat database application as well.
About the network, that's a very great question. In fact, we do rely a lot on NetworkX. But one of the things that I've learned in optimizing anything is, obviously, no matter what tool sets you pick, you're going to hit, some performance limit. So we looked at the networks that we are forming, and we figured out a way to carve the network out to a smaller size, and so we had multiple networks, if you will, of NetworkX object that I can manage within the time frame. So we use that to deploy each network on a Hadoop cluster, and that's one of the way how we tackle that. But even then, we hit a performance limit, and so I had to actually use an open source package from CMU, Pegasus, that massively scales on Hadoop. So there are certain things that GraphX does, which Pegasus does not do. For example, finding the best path and so forth, because we do need to find out how far the influencer or the follower is away from the central topic and whatnot. So those kind of algorithms work better in network. So what we do is we do a lot of back and forth to make that thing happen. But we found a way to carve out the pieces of network and a scale on Hadoop.
I think pretty much everyone's covered it at this point. Issues I've had with Python, or what it doesn't do well for me. Honestly, pandas has changed my life. So I mostly have positive things to say. Nothing top of mind comes to me right now. So, but we can press on, I suppose. I guess Jeb's got it.
I've got another question for everybody. So at the start, we kind of dissected our topic into two groups. So going back to the social media part, what's the coolest thing that you guys have done with Python on social media analytics?
For me, the coolest thing, typically since where I am at today, it's about getting value out of these technologies, right? That's what somebody asked me during lunch. What would you be the one deliverable in big data space that you would tell your customer to, make sense? A lot of my customers have, infrastructure, big data stuff on. They have a Python. There are all kinds of things. But what they're missing is how do I get the business value from what it is? So from that perspective, in the social media, what we are doing today is, when you are, let's say, a premium customer of a company, that company knows a lot about you because you transact with them, you tell them stuff, and you are probably giving some feedback and what have you. They know a lot about you, and they use that to help you to get better service. But the question that some of my clients are asking is that enough? How can I find more of my premium customers in a space that I have no information about? To us, social media gives us that framework. Let us say, we both fly different airlines, right? For example, but we both may be active on a social media and having similar conversations. So if you and I are like-minded in terms of what we say and what we like, if you have information to your company, and if they can somehow socially engage with me, potentially I could be their customer too. So that's the kind of coolest thing from your question perspective, makes sense, because we are now actually using social media to add value. When we say value, it's not about just selling something. It's about how can I make things for you, because this is a connected world. Like, we all need different services to do what we want to do. How can I offer additional services to you so that you can do what you do the best? And that is the coolest story from my perspective.
So, to me, I think, generally speaking, taking Python aside momentarily, one of the most interesting things looking at social media has just been how human it actually is when you actually look at a lot of posts. And some of that, unfortunately, ends up really meaning it's noise, and you have to take it out because it's just an anecdote about some of the, say you're looking at a product or a brand that you're trying to explore the conversation around. And yet, seeing those things, you're like, these are people who you're otherwise completely anonymous, that you are seeing their posts, you're seeing what they're thinking. I think interestingly enough, ultimately, I'd like to have to do less of that. I'd like to be able to write a product so good that it pulls data from the right vendors, uploads it to the right crowdsourcing platform, codes it the right way, applies the right machine learning, and spits out. And yet, that would be great, and that's probably what we need to do. We need to get it to that level. But having that human element in between, where I have to actually look at things and use my knowledge of pop culture to be like, oh, this is not actually about that company. This is about some cartoon or 80s TV show that's actually referring to it like Alibaba or something like that. So that human aspect to me has been really interesting looking at social media. But from a Python perspective, I also look forward to putting it all together so well that I don't need to do that and I can sleep more at night.
So I think, especially in the marketing research space, there's been a fundamental shift where where the modus operandi used to be send out surveys. There are people whose job it is to go to households all over America and sit with people, with these families, and ask them questions, these long booklets of questions that ask them from, questions like the TV shows that they watch or the brand of toothpaste that they use and their attitude towards NASCAR versus Indy 500. And it's this really thick booklet. And just imagine, the amount of investment that used to go into collecting these surveys actually still does. I mean, these companies are still doing it, companies like Simmons and MRI. So it's a huge operational challenge. And obviously the cost is very prohibitive. So if you want to use the survey data, you have to shell out a lot of money. And a lot of smaller companies, a lot of smaller brands don't have that ability to pay that much money. But now what's happening, the fundamental shift that's happened is instead of asking people questions, you infer their opinions from what they're saying on social media. And, obviously the barrier to entry is much lower as well when you're working with social media data. Obviously, that means that there's a lot more noise as well, and there's that bias you introduce by simply having to infer a person's opinion from what they're saying, as opposed to just asking them what they're saying. So an example I'd give you, and to answer, again, the coolest project that I worked on was for LeBron James, who is a client of ours, and we're helping him become the CEO of his own brand. So that's an interesting way to think about athletes these days. Someone like LeBron James isn't just a player. He doesn't just, shoot hoops. He is the CEO of his brand. He's the spokesperson for Samsung. When he wears Beats by Dr. Dre headphones, that, spikes sales of that product infinitely, not infinitely, but by quite a bit, significantly. And so to take everything that's being said about LeBron out there and then establish what his brand actually is today, what do people associate him with? Is it Is it Kia that I think of when I think of LeBron James and the kind of car that he drives, or is it Ferrari, or is it Beats by Dr. Dre, or Kose headphones? So when you help him establish his brand, what it is right now is, does it appeal to young urban males, or does it appeal to older 50-plus women? And then what he aspires to be 10 years from now, you can use all that's being said about LeBron in conjunction with the different brands that he has sponsorships with today, and tell him, advise him that, hey, actually, the sponsorship that you had with McDonald's was not very resonant. Like, people weren't looking at it very favorably. Whereas the sponsorship that you had with Beats, made a lot of sense to people. It resonated with people. It contributed to your brand, and it also will help you take your brand to the place that you aspire to be in 10 years from now. You can start to do that by using all this data that's available out there. And so I think that was kind of a cool project. I also see a lot of confused faces in the audience right now, so I'd also ask you guys, what would you be interested in us talking about? Or are there specific areas that we can talk about or focus on that might be interesting? Sure.
The one that comes to mind is the creepiness factor, like what happened with Target. I think it was 2008, 2009, when when they used their shopping behavior, and a father found out his teenage daughter was pregnant because of the ads. How do you overcome things that would basically do things like freak someone out because of how much you know? How would you make it seem more inferred and less overt?
So, I think the answer to that right now we're in what is the wild, wild west of social media. Like, it's free for all these social media platforms are open, anybody can look at what you're saying. And so in this wild, wild west, the moral responsibility falls on us, people who are analyzing that data, to make sure that you're following best practices, you're holding yourself to a high ethical standard. And I know that will not make any of you, or especially people who are not in this room, very comfortable, that it's a bunch of nerds who are holding themselves to high ethical standards. Nobody wants that. So to make those people feel at ease, I would also say that this Wild Wild West is going to end pretty soon. Recently, Facebook announced that they're cutting off access to even their public Facebook posts to marketing agencies, or anyone actually. Like, anyone right now could go and search for all the posts on football or on NFL right now that are public. So, their privacy setting is public. And that's going to stop. So Facebook is anonymizing that access. You can find out what topics people are talking about when they talk about NFL, and what the demographics of people are, like age groups and gender, when they're talking about NFL. But you won't actually get to see that, hey, this is a person who came into my Target store. She's now on social media talking about, I don't know, condoms, and therefore she's probably pregnant. You won't be able to do that. That individual matching ability is going to become much harder, even though there's research coming out of MIT that, yeah, sure.
It's a really interesting question. I think we can think about it another way. When you're speaking with people, person to person, you're having a conversation, and sometimes something crosses your mind that you realize, maybe I shouldn't say that. I'm not going to bring up all the problems that his sister's having, whatever, because there's a group. It's a conversation. And I think what gets lost sometimes is some of this social data is not only fun and interesting, it's monetizable. We can make money off of it. And I think what gets lost sometimes in the translation from kind of the modeling side to the product side is, at the end of the day, what you're applying your social data towards needs to still be social. It needs to be part of a conversation that's not that much different than what we might have. And, to come straight back to the Target example, don't have conversations about somebody's potential pregnancy when a lot of other people are in the room, right? I mean, I think it's that simple. It just kind of got lost in the translation when they had these monetization objectives.
So I consult a lot of my clients at the enterprise level in the data warehouse and BI space. You probably have heard this thing called data governance. It's a very important factor. And so now, to the point, a very great question about the social media is available, and so my goal is to monetize. I can do anything I want, the Wild Wild West. So some of the things that some responsible enterprises are learning from this experience is any knowledge that you derive from no matter what it is, your transactions or social media need to be governed. Today, there are a lot of laws about what information I can use to approve a loan or not, right? There are some rules. So likewise, those rules are self-imposed, if you will. That's what I think you said, that, it's all our practitioners like us need to be very cognizant of it. So, a lot of times when I implement machine learning rules, engine processing results, we also ask our enterprises, okay, please put in a governance structure around it. And we talk about it before we implement. Some organizations are good at that and some are not. But eventually, that's one way to police these things that happens.
So I think it's been pretty well covered, unless anyone else wants to touch on that. I mean, certainly the one other factor is the source themselves, and like Faiz said, Facebook, for example, are aggregating and anonymizing it, monetizing it themselves effectively through a third-party vendor. And I think Twitter's about to do the same thing for some of its data. Or
sorry, I'm not sure if they'll anonymize it completely, but yeah, they're certainly building more safeguards around it.
Yeah, so I guess, that's sort of a to be continued. But any other questions?
Yeah, moving from philosophy to programming with Python, there's already a regulation in place today. It's called PII, Personally Identifiable Information. So how does Python, or has anybody invoked Python code to actually apply PII regulation?
So I guess I'll repeat the question. Well, first of all, do you seem to understand it better? PII, I'm not familiar.
Well, I don't know if Python, the question is, are there any artifacts or libraries or guards to enforce PII in Python? I'm not aware of. Okay.
I thought you were asking the audience in general, have you implemented that? I work at a company where we have compliance regulations, so we have to think about their PHI, PII. It's a Python-based application.
Oh, is it?
I mean, I don't know if I just was trying to raise my hand because I thought you were asking.
Okay, so what we read from that is there are people who do that.
Yes.
Would you like to hear more about that?
So she's written actual Python programs to invoke PII regulation or HIPAA to enforce that. Fabulous.
Right, so, okay. Great. I'll just have you restate what you just said.
Well, I work for Omega, and we have a product that is bound by HIPAA regulations. It's in the healthcare industry. It's written in Python. It's very mature. Its first release was in 2003. It's all, a Python, JavaScript application with an SQL backend, and our customers really care about this issue. And so we have to have a lot of security functionality in our application to track who all has actually seen the data as they navigate through our application, as they generate reports, who all has actually modified it. And so there's a lot of sort of audit reports that are required for personally identifiable information, and PII is personally identifiable information, and PHI is personal health information. And so these are both areas of concern. And there's also a lot of processes that your organization has to put into place to ensure that you have security controls on who has access to that data. And you have to be able to demonstrate that that your application has those controls. I don't. Is that enough information? Yeah.
And I think that's just it, is that you need an organization like HIPAA to really get a majority of people to follow such rules or to actually enforce any such guidelines. But yeah, I mean, does anyone else have any experience with that? Or panel? Here.
So I think you were talking about this yesterday as well. The regulation, one thing to just be aware in this case is that regulations sometimes fall behind technology as well. So even though there are lots of regulation around what kind of credit card transaction data companies can collect, they're like, it has to be anonymized. You can only record the amount and I think the place where it happened. There are 3 data points. I forget exactly what it was, but it's very strictly defined. But recently an MIT paper came out that said that that's enough. Like those 3 data points are enough to actually pinpoint the person who made that transaction by just like harmonizing different data sets and combining those different data points. So just one thing to be aware.
Just to add to that point, in a previous life, I worked with a database marketing organization, and my takeaway from that is what falls under PII, because like a Twitter hashtag, like you say, regulation kind of falls behind technology. Someone's address obviously is personally identifiable, but a Twitter hashtag, how would that fall in your opinion? Because my experience, it had safeguards around address and telephone number, but if you have someone's email address and you can get their hashtag, I think it's a pretty short trip to be able to identify that person based on the information that this company was gathering for many other companies. So that was just an observation I had in that experience.
I think that's a really important point, and again goes to show that you need to put guardrails in yourself. So one thing that Facebook does or is going to do, for example, is not give you any data point where there are fewer than 100 people that talked about that issue. So things like a hashtag, if there's only one person who's talked about who's used that hashtag, and if even if you scrub out their handle, you're able to identify them by retroactively looking for that hashtag. But with those kind of guardrails where you're aggregating data and you're saying that if it's fewer than 100 people who use that hashtag, we will not show that information to you. So definitely, I think the regulation is probably not enough in this space, and more needs to be done.
The definition of PII is constantly changing. The old definition included not your email address and hashtags, but the newer definition includes that. Therefore, when people are implementing any procedure, they have to upgrade that for including in the new definition.
So the question is, how much does PII change? Like what cadence, how frequently?
I am a user. I just follow that, but I have been noticing it only very recently. The definition of PII has changed. It has remained static for a very long time. So I do not know the frequency they are planning to use, but like you mentioned that if you look at your hashtag, there is a lot more personal information just from the hashtag. So that is why they want to protect those kind of information. So I do not know of any periodicity there.
Each industry is different. From a financial industry perspective, there are about 7 levels of PII at this moment. It could be more. It depends on IT also. And also one point about PII is no matter what kind of programming languages you use and what kind of, it's at the data, actual control, access and control. Think about even you encrypt it, you got to separate the encryption key from development versus production. There are a lot of issues, and that's the biggest challenge in the big data space because it's a lot of unstructured data. And a lot of the comments that are coming in, a lot of the customers, they put in their bank accounts, for example. How do you encrypt it? How do you safeguard it? When it goes into the final the data stores, how do you, scrub it and then make sure you put a hash on the top of it so that nobody can see it? it's the biggest challenge out there. One question for you guys. What kind of technical challenges you faced in terms of the size of the database, dealing with, complex, even the complex Python programs? I know there are lots of limits that are being broken and then being challenged, but what kind of limits that you guys have seen in terms of the sizes of the databases and data sets?
Right. Again, from my perspective, 3 to 4 million edges and having to translate that into a graph, a network, that's been the biggest sort of challenge. So that translation from rows to a connected graph. So if you're getting simple tweets, for example, it tells you the handle of the person who said something, maybe the handle of the person that retweeted, that they retweeted, and some structured information as well, but like constructing networks out of it. That has been a challenge, especially with Python. It's right now actually not even terabytes, several hundred gigabytes, so half a terabyte in some cases, but I've never, even 4 to 5 million tweets, for example, wouldn't translate into a terabyte.
Yeah, if I could add to that. There are a lot of definitions of big data. I think one of the more interesting ones I've heard is, the data are so large that you need to take the analysis to the data rather than bringing the data to the analysis. The first couple of years I worked on Hadoop, it was really rough. There wasn't a lot of standardization. You wound up with data streamed out as serialized Java objects. It's hard to play in that environment. I think more recently you've seen a lot more standardization around file types. You've got Avro, you've got Kite. Almost everything will. People don't fight you when you want something in Hive these days. So I did a fair bit of work with some MapReduce programs in Python. I found that to be very effective. Also relatively easy to do on an environment that was not very beginner friendly early on. Spark, though, for me, has really changed a lot of things. It's a much more efficient data access paradigm for large data sets. It still has some reality constraints, just like anything else. However, I'm able to do a lot more with Spark and a lot less code, more efficiently than I was able to do before. So that's been a tool I've really been using. This one is this data set we got. I don't remember, maybe a terabyte a day coming in, and it's you can't read it all, but you can, if you index it right, you can read enough of it.
I would agree with the same thing about using Hadoop MapReduce in Python or Java helps us to manage the performance challenges. As I earlier mentioned, there's always some business knowledge that you can incorporate to manage your performance, right? People say that, 80-90% of the world's data is going to be unstructured. But how much of that applies to your organization? If you put in that context, it isn't big. So up in the game, in the stream, you apply the necessary filters to manage your performance is one way to tackle that. But, aside that, you do need infrastructure like Hadoop, and I like the way you said about, using Python itself, but using Hadoop streaming, you can run MapReduce code, and that works beautiful.
So I think we're just about out of time. Yeah. Do you have anything else to add, Faiz? All right. Well, I guess that wraps it up. If there's any really, really pressing things before we say goodbye. Thank you all very much.